November, yeah. Yeah. All right. So let's just make sure that we can handle these problems. So look through your notes. This is what I was talking about as far as you have to remember some stuff from geometry before. So what do these little lines mean? Congruent. So they're saying these two angles are the same, these two angles are the same, those two angles are the same. So that means that these lines that are cutting into the angles are called angle bisectors. They cut them in half. And so which triangle point of concurrency would give you angle bisectors? This is where you start flipping through your notes. Angle, the incenter. Okay. What about the next one? So the two angles are the same, so all those were bisectors. All right, so this one, each of these is going to be, these are the same, these are the same, these are the same. So we have to be careful because we have one that has a perpendicular bisector and one that has a median, and both of those cut the lines in half. We just have to know which one it is. So are these perpendicular bisectors or are they medians? They're medians. We know that because there's no little square here to say that they're perpendicular. They are not perpendicular, which means they're medians, which means that this is what? A centroid. All right, I can see that these are saying the lines are perpendicular. So I have two different centers that came from something that was perpendicular. One came from perpendicular bisectors. One came from perpendicular lines that are called altitudes. So are these altitudes or are they perpendicular bisectors? There are two different centers that use perpendicular lines. One is altitudes, so it's just saying how tall the triangle is if that side were the base. The other one is perpendicular bisector, which cuts the sides in half. These are altitudes because they have no markings to tell us that this side and this side are the same. In fact, they're definitely not. You can tell they're altitudes because they go from the side through the vertex, right? So it's showing us the height. This is nice because it's an acute triangle, so it looks kind of tidy. But these are altitudes, which means what is the center? What type of center is it? Orthocenter. Okay, so over here, this time we've got perpendicular lines, and we've got these little markings. This is a circumcenter because they're perpendicular bisectors this time. It's a perpendicular line, but it actually cuts it in half. So perpendicular bisector means that this is a circumcenter. I don't know. And aren't you glad we only study 4 and not the hundreds that people have come up with? I don't know. Everyone's like, no, I have the center of a circle or of a triangle. Yeah. Say it again. Yeah, so if we look at this, they are showing us that this line is perpendicular. That's why they have the little box there. But they're also saying that it cut the side in half. So this is considered to be a perpendicular bisector. So it's perpendicular, but it cuts it in half.
So like, centroid is that without the perpendicular? Wait.
Yeah, centroid is like this without the perpendicular part. Orthocenter is the perpendicular part, but not the bisector part. And then incenter is the weird one. It's just the angles, yeah. Okay, so it says that point G is the centroid. Somebody remind us about centroids again.
Where medians are concurrent and the median connects to the vertex bisects the opposite side.
And it bisects the opposite side, so we know that like this one cut through right here. So if this length is 8, what does this length have to be? 8. Okay. What else do we know?
That the other side, the side that's beyond 10 would be 5.
Okay, so this is the one that has the ratio, right? The part that connects to the vertex is twice as long as the part that connects to the side. So if this is a length of 10, that one's a length of 5. Okay? They tell us that from C to D, that all the way across this line, let me go ahead and... 5 is the short little part, 10 is that long part. Okay, if we look at from C to D, this part right here is going to be twice as long as this part right here. And I'm going to go ahead and show you, some of you guys can do that mental math really easily, some of you guys not so easy. So I'm going to label this as X, and I'm going to label this as 2X because I know it's twice as long. Does that make sense why I'm labeling it like that? So then I can say X plus 2X equals 18, which means that 3X equals 18, and so X equals 6. And that's a way that you could do the math if you couldn't do it in your head very easily. Okay. All right, I don't know, do we have to label anything else? I think that might be it.
I'm still confused as to how we know that these are splitting through the middle. Like, do we know that because it says it's like described with a centroid?
They said the word centroid, and as soon as they said centroid, we know. All right, so from B to D is a length of 8. From A to B is a length of 16. E to G is 5. From A all the way to E is 15. Oh, that's right. The 10 and the 5 is 15. From C to G, 12. And then from D to G, 6. Okay. I'm going to skip number 6 because I think you guys can do that. Let's look at number 7. Which point of concurrency has an inscribed circle? In-center. I remember that one because in-center and inscribed. Get it? Which point of concurrency is the center of a circumscribed circle? Circumcenter. Circumscribed, circumcenter. Okay, we handled that, okay?
Are you talking about the circle? Like, where is it on the triangle?
So, yeah, so this one, the circle is called inscribed because it's inside the triangle. And then here, the circle is circumscribed because it's outside the triangle. Yeah. Huh? Yeah. Okay, you guys have to do 6. Can I what? It's a bird's eye view. It's like a rectangle.
Oh, I thought it was like the notches and things the ground and the shaded in was the sky and the house.
Oh, no. No. Mm-mm. All right. So here, this is kind of testing if you can flip through your notes fast or not, because you're going to have to flip through your notes a lot for this one. So, which points of concurrency are always inside the triangle? Hold on, let me look at my answer key. All right. Centroid and in-center, yes. The other two, the orthocenter and the circumcenter, those are the ones where it's outside the triangle. In the extreme case, where you have like an obtuse triangle, that's when they happen outside. Yeah. What point of concurrency is always on the vertex of a right triangle? You're going to have to look through your notes. It happened in one of the example pictures. D, it is orthocenter. Can everyone find that picture? Which point was the point of concurrency? R. It was right there, the vertex. Okay? Which point of concurrency is always on the midpoint of the hypotenuse in a right triangle? There's another picture in your packet. You're going to have to look for it. The point of concurrency is the midpoint of the hypotenuse of a right triangle. So look through your notes. It is the circumcenter. So everyone find circumcenter in your notes. And look at the right triangle. And you can see that the point of concurrency is the midpoint of the hypotenuse. Does everyone see that? That will always happen in a right triangle. Okay, so if you have a right triangle and you were looking for the circumcenter, it's always going to be on the hypotenuse in the middle. Which points of concurrency are always outside of an obtuse triangle? D and A. Yeah. Which point of concurrency is the center of gravity? C. Centroid. Which point of concurrency is equidistant from every vertex? Did you say A?
Yeah.
So which one is it? I heard A and C. Which one is it? A. It's the circumcenter. Mm-hmm. Yeah. The three altitudes of a triangle intersect at the... Don't answer, Daryl. The three altitudes. Orthocenter. The three medians. The three medians. Centroid. Okay, so these questions are just helping you practice, look through your notes, and remember the special properties for each one. Okay. You're going to have a really good cheat sheet. Yeah, like a lot of the time, yeah. The EOC, yeah. The EOC questions, I've been trying to give you questions that are not as straightforward to prepare you for that, so that when you get to the EOC, you're not like, well, this is totally different. But I would say the EOC, it's like 35 questions. Oh, I don't know if that's the NCFE or the EOC. I need to look it up. But the EOC is completely calculator active for Math 3. It is not for Math 1, but it is for Math 3. There are multiple choice questions. There are gridded response questions where you like put the number in there and you like fill in the blank. There are like matching questions where you like drag and drop an answer because you're going to do this on the computer.
So like your former system better on the EOC or on yours?
So the thing is, the EOC was new last year, and it didn't get a grade, and I did not teach Math 3 last year. So I taught Math 3 when it had an NCFE. I did not teach it when it had an EOC. So you guys are the guinea pigs. Yeah. But what I will say is I've been very deliberate to make sure I'm covering everything that's on the EOC. So like I've looked up the specifications of like what is supposed to be on there, and I'm covering all of it. It is, as of right now, it's counting. We haven't heard anything that says it wouldn't count. Yeah. Okay. Yeah, that's fine. All right. So let's go ahead and look at the next one. We've got some story problems. So it says this rectangle represents the Joneses' lot. When it says lot, you're good. This rectangle represents the Joneses' lot. The non-shaded triangular region represents their backyard.
Wait, we have to put this down wearing socks.
Okay.
All right, the Jones want to build the largest possible circular pool inside their backyard. So don't say it out loud. I want you to look through your notes and think about how you could find the center of the largest possible circular pool. Don't say it out loud. Look through your notes. All right, so what would you do? Yeah.
From the in-center.
You would find the in-center. Why would you find the in-center?
Because the spec is confused.
Yeah, it has an inscribed circle, right? So the in-center is the triangle where it's like, yeah, you can fit a circle inside of that, and the in-center is the center of the circle. So we're going to say find the in-center of the triangular backyard. Okay. A construction company has been hired to install a new water fountain at Winstonian Park. They would like to find the best location so that the walking distance from each of the main pieces of the playground equipment is the same. So they want to put it inside so that you can get to each of the different things with the same walking distance. Unless I read your lips wrong. Say it again. No. Hold on one second.
Told me to hold on, and you have to hold on to your hair.
Wait, teachers, please find the directions. Please send all cross-country, volleyball, and men's soccer to the gymnasium to change for pictures. Thank you.
So Mason, which one is it?
Is it Circumcenter?
Mm-hmm. It's the Circumcenter because the Circumcenter is equally distant to each vertex. And each of these is considered a vertex. So if you want something that's equally distant to each of the vertices, then you want the Circumcenter. Okay, so we're going to say find. But we know that the way that a circumcenter works is that from the circumcenter to each vertex is exactly the same distance. So find the circumcenter of the three main pieces of playground equipment. Okay, last one, don't say it out loud. You're a sculptor, you've made a big metal sculpture. You want to hang it using one piece of string to hang it from. And you want, when it hangs, you want it to hang perfectly parallel to the ground. How are you going to figure out where to put that one piece of string? Don't say it out loud. So they gave you this picture, but it could be any triangle. I'm waiting for somebody who hasn't answered yet. No, you've answered all day. Put your hand up. Put your hand up. I know, but you answered the last one. All right, Sierra, what do you think it is? Mm-mm. Anybody else have a guess? It's the centroid. Why is it the centroid? It's the center of gravity. Yeah. So you're going to find The centroid. All right, find the centroid. That's it. All right. There's more. We could do some more of these. How are you guys feeling as far as like knowing how to look through the packet and look for things? A little bit better about it from last night. Really, it's just a lot of like little factual pieces of information about triangles to like memorize is basically how it feels. I did put some examples of different math questions they could ask, so let's go ahead and try a couple of these just to make sure we're comfortable. So it says in the diagram we have perpendicular bisectors that meet at point G, which means that this is the circumcenter. So right here, so let's go ahead and turn in our notes to the circumcenter part. And then what are the interesting things that we know about a circumcenter? What do the notes tell us? Say it again.
It doesn't have to be inside the triangle.
It could be outside the triangle. What's another interesting thing about the circumcenter?
That distance from the vertices to the circumcenter is the same.
Okay, so the distance from the center, the circumcenter to each vertex has to be exactly the same. Okay, so right here they're telling us that the distance from the circumcenter to the vertex C is 25. So what's the distance from G to A? Also 25. What's the distance from G to B? Also 25. Okay. Now, these lines are perpendicular bisectors. So if this is the perpendicular bisector right here, and this is 20, then what should this be over here? 20. And this is a perpendicular bisector, and this is 15, so what should this be? 15. And then for F, this little thing, this is a perpendicular bisector right here. So if this is 24, then what's this? 24. Okay, so let's fill in the information. The length of AG from A to G is 25. What about from B to D? What about from C to F? This one is C to G. Yeah, C to F is down here. A to B. C to E. A to C. The measure of A to D to G, so the angle from A to D to G, that's a 90-degree angle because it's perpendicular. Okay? If the length of BG equals the expression 2x minus 15, we got to solve for x. Okay, but not 30. BG is 25. So 25 equals 2x minus 15. Add the 15 to the other side, which gives you 40. 40 equals 2x. X equals 20. Okay? Okay. The next one also has perpendicular bisectors, which means it's a circumcenter, so the next problem is going to be very similar to the one we just did, so we're going to skip that one. I think, did we do an in-center one on the last packet? No. Oh, that's the angle bisectors ones. Okay, so let's look at this one. So, point T is the in-center. What do we know about in-centers? Look at the in-center. The angles are bisected, right? So the lines that bring you to the center are angle bisectors. Okay, so if we look at this, it says point T is the point of concurrency of the angle bisectors. Okay. let's go ahead and label as much as we can. Did they tell us anything else about Incenter? Okay, so if this is the Incenter, wait, don't we know something else about Incenter? Incenter has the inscribed circle. Okay, so one of the other things that we know about Incenter is what? Okay, and then what else do we know? The incenter is equidistant. Okay, so from the incenter to the side is a length of 15. From the incenter to the side is a length of 15. From the incenter to the side is a length of 15. And that's because when you make that inscribed circle, the distance from the incenter to the side length is a radius of the circle, so it's always the same. Okay, so 15, 15, 15. So ST is a length of 15. Okay. If TU equals 2x minus 1, then what should we do? Okay. And then what should we do from there? Okay. Okay. Now they're saying measure of angle PRT. So from P to R to T is this angle right here. And that angle is 24 degrees. Right? Okay. So from P to R to T, I just traced it. So if you trace it, then that's the angle right there. Yeah. And it just says it's 24. Right here. Okay. Then QRT is what? It's also 24. And that's because that line had to be the angle bisector since this is the incenter. Okay. If R to Q to P, so RQP, RPQ, just kidding, RPQ is 62 degrees. Then RPT, it's half of that, so it's going to be 31 degrees. So if we read the letters, it says RPT. So RPT is half of that. Because 62 is the whole thing.
But why is it PRT is 24 and not the full thing is 24?
It's because of how they described the letters. Because they said from P to R to T. They just said this half is 24. So the other half is 24. When they said RPQ, RPQ is the entire corner. Go ahead and put an X through 20 and 21. All right, 22. 22 is a centroid. Let's flip in our notes and look at what we know about centroids. These labels are wonderfully hard to read. So it's good that we're looking at this together. So let's look at the first one. What do we know about centroids? They're medians, right? The concurrent point for medians. What else do we know? What do your notes say about centroids? 2-to-1 ratio. So if I trace the median from J to M, I can see it's got a 24 and it's got a 6Z. Which side is the double side? Which side is the one side? The 24 is the double side. The 6Z is the one side. I can tell that the 24 is the double side because it looks longer, but also because it's the side that touches the vertex. Okay, so half of 24 is 12, so we're going to say 12 equals 6Z. And so what does Z equal? Okay. Oop. Then we've got this one. So the short side is a length of 10. The long side is a length of 3y plus 5. Are they equal? Okay. So you have two options. So you can do 3y plus 5 divided by 2 equals 10. That's one option. Or you could say 3y plus 5 equals 20. And just say the longer side, so I'm going to double the short side. So it's the same thing. It accomplishes the same purpose. Yep. Mm-hmm. Okay. So 3y plus 5 is 20. We subtract the 5 over. 3y is 15. Y equals 5. Okay. And then we can go ahead and do the very last one. Which one is the double side? The 2x. So the 12 is the short side, the 2x is the double side. Oh, no, you're right.
You don't have to do anything except multiply 2, but really just pick up.
Yeah. So you could double the 12, and you get x equals. That's hurting my brain. I'm going to say 2x equals 24. So this is the double side, and I doubled that side, and then x equals 12. That hurt my brain so hard, you guys. That really got me good. Okay, so we got centroid problems. Let's jump down to number 25. We got some perpendicular bisector problems. So let's flip through our notes and figure out what the center is for perpendicular bisectors. Circumcenter. What else do we know about the circumcenter? The vertices are equidistant from the center. Okay, so let's look at this. So we've got a couple different things going on. We've got a perpendicular bisector, and since it's a bisector, it cuts the sides in half. So if this is 18, what's this over here? 18. Okay, so we can solve that to get Z. And what does Z equal? 2. Okay. And then what else do we know about these ones, circumcenters? What do we know about the circumcenter? We said the distance from the circumcenter to each vertex is the same. So this is the same as this, is the same as this. Those are all the same. So I'm going to go ahead and say 8x plus 16 equals 24, which equals 5y minus 6. So I'll go ahead and look. I'm going to ignore that for a second. So what do I get first? All three of these are equal, so I just wrote that all three of them are equal, but I'm going to cover this up. So what should I do first? Subtract the 16 over, so I get 8x equals 8. And so x equals 1. Okay, and then I can do it again, but I'm going to look at this one. What should I do first? Add the 6, so I get 30 equals 5y. So this unit is going to be a little bit more about accessing information and knowing how to use it than it is about memorizing something. Does that make sense? This is way too much to memorize in such a short period of time, so I don't necessarily expect you to do that. But I do expect that you have made yourself a cheat sheet and that you can go back and look at it and help it and figure out how to get the answers right. Okay.
The one you make cheat sheets. I've already made it, and I know that's not true. I only have like 5 more.
Yeah.
Too late. I wrote the 10.
All right. Go ahead and flip to the back. Don't say it out loud, but see if you can figure out which one this is. Don't say it out loud. Don't say it out loud.
I didn't say anything out loud.
I mean, you did say something out loud. It just wasn't the answer. All right. What's the name of the center for 31? Incenter. Okay. Don't say it out loud. See if you can figure out number 32. What did you guys get? Are they altitudes? No. It's circumcenter because they're perpendicular bisectors. So I can tell it's not an altitude because it's not telling me the height of the triangle. Does that make sense? So the altitude would have been like that instead. Does that make sense? Okay. Don't say it out loud. See if you can figure out number 33. All right. What's 33? Circumcenter again. (34) and 35 were the only ones I could do without my notes because I remembered my little mental trick of remembering them. The circle is inscribed, so the center is the in-center. The circle is circumscribed, so it is the circumcenter. Those were my favorite questions in the whole packet because I didn't have to look anything up. Yeah, they're very easy to get confused. Okay, so we've done a fair chunk of this packet, right? At this point, we've done a lot of it. So your goal is to finish the rest of it. I am not going to give you homework tonight because I don't have the notes made yet. So, but tomorrow we study parallelograms, and that is the last part of this unit. No, we are taking a test Tuesday. We are reviewing Monday. Reviewing Monday, test Tuesday. Yes. Yes. All right.
That's kind of scary.
Yeah. Okay. Whew. That was 40 minutes.